All right, so this is now video 2, and this is the special cases of substitution or solving systems of equations in general. We talked about this in section 1 in the last video, where what if we have two equations or two graphs that when we graph them, we only had one time where they intersect here, and they were called consistent and independent. Then what happens if we had two parallel graphs? Well, they were called inconsistent since they never touched or never intersected. There was no solution. So no solution, one solution, and then we had another example where if we graph them and the two lines coincided, meaning that they were the exact same lines, so when we graphed them, they were right on top of each other, this meant infinitely many solutions. Right, so this is already something that we discussed. So we know that these cases happen because we've already talked about them graphically. But now we need to go, well, how will these appear, or what will they look like? What will no solution look like when you're solving using substitution or elimination? And what will infinitely many look like when you're using substitution or elimination? We already went over one solution in the first video. The two questions we did, they were both one solution. So it's either one solution, no solution, or infinitely many. All right, so if you get an identity when you're solving a system of equations using substitution or elimination and it says 2 is equal to 2, then that means it's infinitely many solutions. That means no matter what you substitute in for x or y, that when they satisfy the one equation, they will satisfy the both. All right, so it tells us that there's infinitely many solutions that we will be able to plug in. So whatever x and y values satisfy one of the equations, it will satisfy both at the same time. So that means the two lines coincide with each other. That if we were to graph them, that they will be parallel. Sorry about that. That if we graph them, they will be parallel. If you get a false statement, 8 equals 2, which we know is not true, then that means that there is no solution. So no matter what we substitute in, there'll never be an x and a y value that satisfy both at the same time. All right, so let's go ahead and do a couple of these questions. So how many solutions does each of these have? So it already says x is equal to, so it's already set up for us to use substitution. So since x is equal to negative 2y plus 4, I can substitute that into x in my second equation. So it's 3.5 times negative 2y plus 4 plus 7y is equal to 14. Right, now remember here we had two different variables, so we couldn't solve them as is. Now we're down to one variable, y, which we can solve. All right, 3.5 times negative 2 is negative 7y. 3.5 times 4 is 14, so plus 14 is equal to 7y. I'm sorry, not equal to, plus 7y is equal to 14. And now we'll combine like terms, so negative 7y plus 7y, the y's will cancel each other out, as it'll be 0y. And we're left with 14 is equal to 14, which is a true statement. So that means that there are infinitely many solutions. And that if we were to go ahead and graph these two lines, that these two graphs will look exactly the same, or they will be exactly the same, and they will graph right on top of each other. And if we were to rewrite each of these into y is equal mx plus b form, that they will be the exact same line. All right, so now let's go ahead and let's do one more problem. Before we get to that though, just remember when it is a true statement, it is infinitely many. So this would be consistent and it would be dependent. All right, now for this last problem, we have y is equal to 3x minus 11, so it's already set up for us to use substitution. So we will substitute 3x minus 11 into the other y. This one's actually set up pretty easily. If we wanted to solve for this y and say y is equal to 3x minus 13, we can do that as well. But we're just going to substitute into here. So we have 3x minus 11 for y minus 3x is equal to negative 13. So the same thing with the other one, we'll combine our like terms first. Well, 3x minus 3x, they cancel each other out because that will be 0x. And then we get negative 11 is equal to negative 13. Well, that's not a true statement. That's false. That can never, ever be possible. Negative 11 is not equal to negative 13. So since it is a false statement, we would say no solution or inconsistent. All right, so that is it for this video. Pretty short, quick video, but just showing you how the special cases will show up when you're using substitution or elimination. You will get sorry, this one deleted for some reason, you will get a statement that is false, negative 11 does not equal to negative 13, or you will get a statement that is true, that 14 does equal to 14. All right, that is it for this video.